Hello students, I hope you all are fine. Students, today we will discuss about the physical properties of solid, liquid and gas. One property we have already discussed, that is solid. Solid have definite shape. Definite means fixed shape. Definite shape and definite volume. But students, liquid they have definite volume, fixed volume they have, but they change their shape according to the containers. According to the container means they do not have fixed shape. They do not have fixed shape. But gas, they neither have fixed shape nor fixed volume. So this point already I have explained in front of you. Today we will discuss some more properties of solid, liquid and gas. Next point is particles are closely packed. They have minimum space between them. If I talk about solid, students, they are hard, they are rigid. Why they are? Because in solids, particles are closely packed. Closely packed means they have minimum space. They have minimum space between them, like that. Here, let us consider it in regular manner. Okay, this is the space between them. This one is the space. Means in this way they are arranged that they have minimum space between them. Further we cannot compress them. Further we cannot compress. Why? Because minimum space they are having. Okay. So in case of solid, particles are arranged in a proper way, in a regular manner. And they are the closely packed. Solids also are classified into two, crystalline and amorphous solid, but in higher classes we will study about that. In crystalline, particles are arranged in regular manner, but in amorphous, particles are not arranged in the regular manner. Okay, but students, if I talk in general way, then particles are the closely packed. Okay, so they have minimum space between them and they have maximum force of attraction. They have maximum force of attraction. Maximum force of attraction they are having. That's why they are closely packed. That's why they are having minimum space between them. Okay. And due to these reasons, solids are hard. They are rigid. They have definite shape because they cannot further compress. But students, if I talk about liquids, liquids are packed more loosely as compared to solid. As compared to solid, the force of attraction between the particles of the liquid is less. They have less force of attraction as compared to the particles of the solids. Like this. They are far apart from each other. They are far apart. They have more space. They have more space. Why they are having more space? Because force of attraction is less. Force of attraction is less. Not tightly bound they are. The force of attraction between particle is less than between the force of attraction between particles of the solids. Okay, that's why they are soft and they have tendency to change shape. Students, if I have a poly bag, if I have a polythene and you can take one balloon also. If we are filling water in that, okay, and if we compress, so easily we can compress. Why? Because we are filling liquid and liquid particles are not having so much force of attraction between them. They are having space. Then if we will pressurize them, then particles will come closer to each other and they can occupy this space. They can occupy this space. Okay, that's why they are not having fixed shape and their shape can be changed. Shape can be changed because particles are not closely packed here. They are not tightly bound. They have more space between them. But student, this space is less than the space of particles of gases. This space is less as compared to the particles of the gases. If I talk about the gases, this space between particles is maximum here. They are very loosely bound. They are very loosely bound. Maximum space they have. Maximum space. Space they have. Okay, and students, here force of attraction between the particle is minimum. Force of attraction is minimum, because if we will compress this one, they are highly compressible. Why? Because if we will compress them, then they will cover this gap. Okay, so now these particles can come closer to this one. They are highly compressible. So students, in second point we have discussed about the particles arrangement here, about their packing, what type of packing particles are having. In case of solid, particles are the closely packed, they are tightly bound, means they have maximum force of attraction and minimum space between them. That's why solid are hard, solids are rigid, means they have tendency to maintain their shape. But liquid, their particles are far apart. They are not tightly bound. Okay, they are less tightly bound as compared to the particles of the solid. Force of attraction between the particle is less as compared to the particles of the solid. Why? Because they are having more space. Okay, so students, they can be compressed easily and they can be changed their shape. That's why we can say they are soft and they have tendency to change their shape. Particles, in case of gases, particles are very loosely bound. They are far apart from each other. Force of attraction is negligible here, we can say. Minimum attraction they are having and maximum space between the particles of the gases. So students, that's why they have tendency to move freely. I hope this point is clear to you. Some more properties we will also discuss. Non-compressible, already I have discussed. Solid, because already they have maximum force of attraction and space is minimum between the particles, so they do not have tendency to compress further. So we can say their compressibility is negligible, is minimum, and we can say also they are non-compressible. Means they cannot be pressed, But students, liquid have more space. In liquid, particles have more space as compared to the particles of the solids. They have less force of attraction as compared to the particles of the solids. That's why if we will press them, then particles will come closer and they will occupy that space. Okay, means they are compressible. If we will press them, then they change their shape and they can be compressed. But this compressibility is less as compared to the compressibility of the gaseous particle. Okay, if I talk about the gases are the highly compressible. Gases are the highly compressible. You know very well, students, if we release pressure of the gas cylinder that we are having at our home, then within some minutes, what happened? That gas spread in whole the room and in whole house. Okay, small amount can be spread in whole, but after applying the pressure, we can fill in a very small part of the cylinder, that whole gas. Why? Because particles are highly compressible. Particles are highly compressible. If I talk about this room and if I pressurize this one, so the gases, whole number of gases are here, so all whole gases I can compress and I can fill in a corner of this room. Okay, so particles of gases are highly compressible. Non-diffusible. What do you mean by the diffusible? Diffusion. Students, diffusion is the property of the intermixing of the particle. Intermixing of particle. Solids are non-diffusible. Means, students, let us consider I am having one box, and in this I am filling some erasers. Okay, so all are the erasers. All have same type of the shape, same type of shape. All are having same type of the structure. Size also same. But students, because particles of solid are having distinct boundary, I can count them easily. This one is one eraser, this one is second one, this one is third one, and this one is the fourth one. So they here four means they are not mixing with each other. They are not mixing with each other. Why they are not mixing? Because they have distinct boundary. Because they have distinct boundary. Separately. Okay, fixed boundary they are having. So we can identify this one, 1, 2, 3, 4. Here are 4 erasers. Means here particle cannot mix into one another. But students, if I talk about the liquid, let us consider if I have one glass and I fill water in this, and I fill alcohol also. Simply only I can also take. So students, I cannot tell how many molecules of water are present in this one by simple saying. Like that, I can count easily. There are 4 erasers. But I cannot count number of particles, number of molecules here. Why? Because here particles of liquid are not having identical boundaries. Liquid particles are not having identical boundaries. That's why we cannot identify how many molecules are there only by seeing in glass. Okay, so students, we can say here particles have property to mix with each other. They are not having distinct boundary. Means they show diffusion. They have tendency to intermix with each other. But Gases are the highly, they show very high diffusion. Yes, students, you know very well. Here, hydrogen, oxygen, carbon dioxide, other gases also present in our atmosphere, but we cannot identify them. This one is the molecule of oxygen, this one is molecule of the hydrogen. We can't detect them. Okay, why? Because they are highly diffusible. They show maximum diffusion. Particles have mixed properly with one another. Okay, so simply if we not identify them, so they have tendency to intermix with each other. So we can say maximum, they show maximum diffusion, highest diffusion. I hope diffusion is clear to you. They do not show diffusion, they are diffusible, but they are highly diffusible. Then students, our next point is solids are hard and rigid. Why they are hard? Because force of attraction is maximum here. That's why they are hard. And due to that reason also, they have tendency to retain their shape. So that's why they are rigid also. For example, chair, board, pencil, all these, our room, okay, this one also solid. Liquids are soft. For example, oil, water, kerosene, okay. Other examples you can also take like glucose, alcohols, all these are the liquid. Gases, very soft, hydrogen, oxygen, nitrogen, etc. And student, if I talk about their fluidity, solids do not show fluidity. They do not show fluidity. Means they cannot flow. But commonly liquids and gases are known as the fluid. Commonly gases and liquid are known as the fluid. Students, one term is gas, but one is the vapor. What is the difference between them? Before that, we will discuss about the interconversion of states of matter. Are these three states solid, liquid, and gas? Solid, liquid, and gas. Are they interconvertible? Yes, they are interconvertible. Solid can be converted into liquid, and liquid can be converted into gas. Further, this gas can be converted into liquid. This liquid can be converted into solid. Gas can be converted into the solid, and solid can be into gas. Means these states of matter are the interconvertible. But how we can do that? They can be converted from one state to another state by heating or cooling, means by increasing or decreasing pressure and temperature. Pressure and temperature. Like that, if I am having gas and if I pressurize that, then it can be converted into the liquid. Students, the gas which we are using at our home, that is the for cooking purpose, that is the LPG. LPG means liquefied petroleum gas. Liquefied petroleum gas means by applying some pressure in our cylinder, this gas is in liquid form, but when we release the pressure, then it escape out in form of the gases. Means gas can be converted into the liquid also. And here main components are the propane and butane. What are the main components of the LPG? Propane and butane. So students, these three states are interconvertible from one to another. They can be converted by heating or cooling, by applying pressure or increasing temperature. So students, here solid can be converted into liquid and liquid can be converted into solid. If we will heat solid, then it can melt and it can convert into the liquid. We keep heating continue, then this liquid can convert into the gases. For example, if we are having ice, ice is the solid form of the water. Okay, if I heat this one, you know very well, it is very common example. If you will heat this one, then what will happen? Ice can be converted into the water, means in liquid state. And if I keep heating continue, then water can convert into the water vapors. Water vapors. But further, if I cool these vapors or I apply some pressure, so this vapor can further convert into the water. That plate is applying pressure on them and those vapors further convert into the liquid. Those vapors further converted into the liquid state. Okay, so we can say these states of matter are interconvertible. Solid can be converted into liquid, liquid can be converted into gas. Gas can further convert into liquid and liquid into solid. Even solid can be converted directly into liquid. Gas is also in some molecules and gas can be converted into the solid. But students, here I have written gas, but here I have written vapor, water vapors. What is the common difference between the gas and vapors? Students, vapors are those which exist in liquid state. Which exist in liquid state in standard conditions. In standard conditions. Standard condition means standard temperature, at standard pressure. They are lying in liquid state. But when temperature is increased, then they exist in gaseous state. Otherwise, at normal conditions, at standard conditions, they exist in liquid form. But gases exist in gaseous form. In standard conditions. For example, if I talk about oxygen and I talk about water vapors. Students, when I boil water, I heat water, then water convert into water vapors. But when further they attain room temperature, okay, further they get cold, then further vapor convert into the liquid. But oxygen at room temperature, at atmospheric pressure, also existing into the gaseous state. So here oxygen is the gas, but these steams are the water vapor, not gas. So today we have discussed about the physical properties of the solid, liquid and gas, and we have discussed these states of matter are interconvertible or not. So students, tomorrow we will discuss about the process, means what is the name of process for conversion of solid into gas, for liquid into solid into gas, solid into liquids, means we will talk about the processes. So enough for today. Thank you. Have a nice day.